This is the recording for topic 7-2, slope as a constant rate of change. Our objective for today is I can find the slope of a line from graphs, tables, and equations. In 7-1, we found the slope of a line from our graphs and tables. Today we're going to concentrate on the equations, but we will relate it also to the graphs and tables. So your central question can be, how can I find the slope of a line from graphs, tables, and equations? By the time we finish this lesson, you should be able to answer that question. Our previous review problems, we have Jake averages 20 points per game when he plays at least 30 minutes in a basketball game. What is the functional relationship between the total number of points that Jake scores and the number of minutes he plays in the basketball game? What we're trying to find again is what's the functional relationship between the total number of points Jake scores and the number of minutes he plays. A says the number of minutes is dependent on the total number of points. If I thought A was true, that means time cannot pass unless Jake scores some points. Well, we know that time is always going to pass, and so time is never dependent upon anything. So A is not the correct answer. B says the total number of points is dependent on the number of minutes. This means Jake can score points depending on how many minutes he plays. That sounds very familiar to what was stated. So we're going to leave B as a possibility. Let's check the others. C. The total number of points and the number of minutes are each dependent on each other. So that means that the points depends on the minutes and the minutes also depends on the points. Well, in part A, we said the minutes cannot depend on anything. D says there is no functional relationship. Well, it asked us, what is the functional relationship? There is a relationship, and that relationship is B. The total number of points is dependent on the number of minutes. I'm going to briefly put up the answers to assignment 7-1 so you can check them. If you need to, pause the recording in order to see the answers for longer. Here's problem 1 and 2. Again, using the graph or the table to come up with our equation. Problem 3, using the table, making a graph, and then coming up with our equation. Number 4, we have a table, we do our graph, and we came up with our equation. Number 5, this time we had an equation, but we were able to come up with a table and a graph, finding our slope and the rate of change, or rate of change in the beginning. So now we're going to work backwards from what we've done in the past. In the past, you were given a table or a graph and came up with the equation. Today, you're going to have an equation and be able to fill in a table or a graph. The equation of the line that we're going to be using can be written in the form y equals mx plus b. This is known as slope-intercept form because the m represents the slope, which we also know as the rate of change, and the b represents the y-intercept, hence the name slope-intercept form. The y-intercept is where we begin when we're graphing. So this same equation is very similar to the one we used to come up with our equation based upon the graph. Our y is our output, our m is how it changes, our x is our input, and then our starting is where we begin. First thing we're going to do is, given the equation, figure out what the slope and the y-intercept are, and then graph the equation to fill in the table. First thing we're going to do is write that y equals mx plus b either above or below the equation that's given. So we write the y equals mx plus b, I'm writing it below our 3x plus 2. When it's written this way, I can tell that the m corresponds with the number in front of the x. So in this case, our m is equal to 3. Remember that our m represents the change, and we like to have it as a fraction. So I'm going to make it look like a fraction by doing 3 over 1. Our b represents where it begins. This is the number at the end all by itself. The b is 2. When I plot it, though, I plot it as an ordered pair, or I'm sorry, I plot it as the y-intercept. So on the y-axis, our x-coordinate is 0, our y-coordinate is that number 2. So when we start our plot, we're going to start at the beginning or the 0, 2. So I'll start with x is 0, y is 2. Here's my beginning point. I'm going to look at my m. M tells me how my graphs change or how that point moves. So this m is positive. Last week or in our previous lesson, we determined when it's positive, we're going to have an increasing graph. So if I read my graph left to right, I should be rising to the right. This means my m, the top number is going to tell me how far I rise up. The bottom number tells me how far I move to the right. So starting at our beginning point of 0, 2, we're going to rise up 3, 1, 2, 3, and then move to the right 1. To the right 1, here's my new point. From my new point, I'm going to rise up 3, 1, 2, 3, and to the right 1. I have another new point. With these 3, I can connect those dots and create my line. If you don't have a straight edge, I suggest using your ID, placing it on there, and then drawing a line. When you draw your line, draw it all the way through the graph. Mine's a little iffy, but I can always change it. You want to make sure you're going through all 3 points. And then you also want to make sure that you are putting arrows on the end because we are talking about lines, and lines go on forever and ever. So we do want arrows on the end. So you've drawn your line throughout the entire graph. Now we're going to fill in our table. We were given an equation, y equals 3x plus 2. And whenever we give an equation y equals, you should ask yourself, is there any way I can use my calculator? And we are going to use a calculator like we did in our previous lesson. We're going to do y equals in our calculator. We have a button that says y equals, so we'll press it. And now we'll type in 3x plus 2. So 3, x is next to the alpha button, plus 2. With this equation in there, we can hit the second button and then the graph button. Above it says table. When I hit the second in the graph, it is going to bring up a table. Now I can use that table on the calculator to fill in the table that I have on my worksheet. When x is negative 3, our y is negative 7. When x is negative 2, our y is negative 4. When x is 0, y is 2. And when x is 2, y is 8. I'm going to check just to be sure that I drew my graph pretty well. So on my graph, when x is negative 3, my y should be negative 7. And I can tell my graph is a little off. When x is negative 2, my y should be negative 4. X is 0, y is 2, and then x is 2, my y is 8. Those ones that actually work. It's okay if your line is not exactly straight, but it will give you an idea. The other thing that our graph can be used for, the graphing calculator, is to actually look at what the graph is going to look like. To bring up the table, we hit second graph, but if we just hit graph, we will actually see what the graph should look like. So I can pull up the graph and compare it to what I drew and say, yes, it is increasing with a positive slope. That looks about right. And so I think I drew my graph really well. This comes in handy if you are graphing and let's say your graph come out going downward and to the right. Then you know you did something wrong because your calculator was there to help you out. All right, let's go to problem number 2. Problem number 2. Again, the first thing we're going to do is write the y equals mx plus b above our equation. With the y equals mx plus b, we can find our slope. The slope is the number in front of the x. Our m is equal to -2. To make it look like a fraction, we're going to do -2 over 1. This helps us when we graph. Our b is the number at the end, so b is equal to a +5. But when we graph it on the y-axis, so 0, 5 is our ordered pair. Looking back at our slope or rate of change, we see that it's negative. That tells us our graph should be decreasing. So when I draw it, it should be going downward to the right. When I use my slope, the top number is going to tell us it's going down because it's negative, and the bottom number tells us to go to the right. So let's start at our beginning. We're going to begin at 0, 5. Our point begins at 0, 5. From our beginning, we're going to go down 2 now, down 2, to the right 1. We have a new point. From our new point, we're going to go the same pattern, down 2, to the right point, to the right 1. From that new point, we go down 2, to the right 1. See how the m, or the slope, is helping us move that point. We go down 2, to the right 1, and we're going to fill in all the dots throughout the graph as far as we can go to our right. Okay, with the straight edge, we're going to connect the dots. You may use your ID in order to help you. The more dots you have, the better your line's going to be. Again, we want arrows on both ends. Now that we have our dots, we have our graph. Now we can use our calculator to check to see if we graphed it correctly and also to fill in our table. So let's first check to see if we graphed it correctly. Go back to y equals. This time we're typing in a -2x and then +5. Hit the graph button. I do have a graph that is decreasing. I do see the y-intercept is somewhere at the top. It's very hard to read those tick marks, so that's when we're going to go to our table. Go to the table, we hit the second and then graph. And then we'll use our arrows to scroll down. When x is -1, y is a +7. Let's check. When x is -1, y is a +7. That worked. When x is 0, y is 5. Sure enough, that's what we have on our graph. Scrolling down, when x is 3, y is -1. Check that. When x is 3, y is -1. Yes, that is a point on our graph. And the last one, when x is 5, y is -5. So we've used the calculator to check our points as well as to help us look at the graph and make sure that we have the correct graph going on. Let's look at our last problem. Again, let's start off with y equals mx plus b. Write it above your equation. We're going to partner up. The number in front of the x, that's our m. This time it's a -1/4. When we have negatives, we're going to always put the negative with the top number, because that top number will tell us whether or not we move up or down. Since it's negative, we're going to go down 1. The bottom number will tell us go to the right 4. Notice our bottom number, we will always graph going to the right. Our b is the number on the end. This time there's a -2, so our b is actually a -2. Whatever sign is with the last number, that's what our b, it has that same sign. So the point, or y-intercept, is 0, -2. We'll start at our beginning, 0, -2. Here's our point that we begin with. And then this point's going to move by going down 1 to the right 4. 1, 2, 3, 4. We have a new point. From that new point, we'll go down 1 to the right 4. 1, 2, 3, 4. And then I see I can't go any further on my graph. I can go down 1, but not to the right. All right, let's connect our dots. You use a straight edge. I'm using the computer, but I can adjust it afterwards. Make sure you draw your line throughout the entire graph. When you're tested, you're going to be tested on drawing the line throughout the entire graph. Again, there must be arrows on both ends to show that the graph or the line continues on. Now we'll fill in our table using our calculator. Let's go to y equals. We'll clear out what's in there. We do have a fraction, so this time we'll put in parentheses, -1 divided by 4. Remember the negative, put it with the top number. Close the parenthesis and then the x, minus 2. Check the graph. Let's see if we have a similar graph. It looks very similar to what we have on our paper. And last is going to check the table. We need when x is -8, I'll scroll up using arrows. When x is -8, y is equal to 0. When x is -4, y is -1. When x is 0, y should be -2. And when x is a +4, y is going to be -3. Let me check my picture. I could probably draw this a little bit better. Let's see. At -8, we have 0. My line looks like it's at -7, so again, I have a computer I can adjust. You have an eraser. At -4, our y value is -1. That is on our plot. At 0, we're at -2. And at 4, we're at -3. Our final task with our notes is let's summarize what we learned today. In previous lessons, we found the slope from graphs and tables. Today's lesson, we found the slope from an equation. So to summarize, in order to find the slope from the equation, the first thing we did was we wrote y equals mx plus b above the equation or below the equation. When you write it above or below the equation, then you know your m represents the slope and b represents the y-intercept or the beginning. Using those two terms, you are able to graph. And lastly, we used the y equal in the calculator to actually see the graph and the table. Your summary may be different than mine. I just went over the key points. Now it's time to do the assignment, but I wanted to go over one of the problems with the assignment with you. If you will get your assignment and look at problem number 4. Problem number 4, you're identifying what the slope and the y-intercept is for the line that's given. We're going to start with our first task, again, writing y equals mx plus b across the top or below. Notice that the number in front of the x that's given, we have a negative x. That number in front of that x is a -1x. So this means that our slope is actually a -1. To write it as a fraction, that's -1/1. The y-intercept, I don't have a number at the end. There's nothing there. So the number that represents nothing is 0. Our y-intercept is 0. That means we're going to start off at 0, 0, or the origin. From 0, 0, our slope tells us we're going to move down 1 and to the right 1. Move down 1 and to the right 1. And we should be able to fill in the dots throughout the entire graph and then connect the dots. Most students got a little shaken up because, hey, there's not a number that followed after the X, and also there wasn't a number in front of the X. But we understand anytime you have a variable and no number in front, there's an understood 1. This time it's a negative 1 because we did have a negative. This concludes topic 7-2.